So polynomials are these friendly functions that have this form. Now that looks really busy, like a lot of subscripts and superscripts, but we've already looked at polynomials. For example, a quadratic function is a polynomial, or a line, a linear function, is a polynomial. And this is basically called the leading coefficient. It's the one that's with the highest degree, or the highest power that you see. And n, the highest power that you see, is the degree of the polynomial. So basically for a quadratic, the degree is 2, and the leading coefficient in this one is a 1, if there's only a 1 there. And here for the linear function, the degree is 1, and the leading coefficient, since with next to the x to the 1 is the 3, would be 3. For example, this is another polynomial. It's got degree 3, and the leading coefficient is 4. If you have things like, let's say, f of x equals 10, a constant, then the degree of that is automatically going to be 0 because you see no variables and no x's involved. So polynomials are these what's called friendly, smooth, continuous functions. And when we say smooth, we mean no sharp corners. So there's no sharp corners or edges in their graphs. And when we say continuous, there's really no gaps or holes in their graphs. So things like, a parabola, you can draw it with one stroke of a pen or a pencil, or a line, you can draw it with one stroke of a pen or a pencil. There's no gaps, there's no holes, there's no stops. We've also looked at things like x cubed, and that we said looks like a snake and goes through quadrants 1 and 3. So these are all polynomials, and they're usually the friendliest functions you can look at. Our goal will just be to see what the end behavior of these polynomials are. We're already used to them. They basically look like x squares and x cubes. So for the end behavior, I mean what happens to the y values as x goes to infinity and negative infinity for polynomials. So if I have an even degree for a polynomial, it's basically going to go and look like that. And then what happens in the middle could be crossing the x-axis or not. An even degree with a positive leading coefficient, so if a sub n is positive and the degree is even, your graph will look like that. If a sub n is negative, meaning the leading coefficient is negative as n and n is even, your graph will open down, and then what happens in the middle could cross the x-axis several times once, or however many times depending on what the degree is. So the end behavior of an even degree is basically like the x squared function. That's how it behaves. That's basically the bottom line for all polynomials. Evens act like that in the edges, going up if the leading coefficient is positive, and act going down if the leading coefficient is negative. For example, if I have something like, 4x to the 4th plus 3x minus 1 for my polynomial, it could look like this graph that's opening upwards in the edges. And if I have something like, let's say, g of x negative 3x to the 6th plus 4x, it could look something like this with the edges opening down. As x gets really large going to the right, or really small going to the left to negative infinity, basically it's going to open up or down. That's the end behavior of all polynomials that have even degrees. For odd degrees, you may have already guessed, it's going to look like the x cubed function. The edges, as x gets to infinity or negative infinity, if a sub n, meaning the leading coefficient, is positive and n is odd, there could be things happening in the middle with x-intercepts going through the x-axis, but the edges basically look like that, going through quadrants 1 and 3. For example, if I have a function like, 4x cubed minus 4x plus 1, it could look something like that, where it goes through quadrants 1 and 3 in the edges. If I have an odd degree, but my leading coefficient is negative, again, it's going to look like it's going through quadrants 2 and 4 as x gets large on the right and small. And what happens in the middle, we don't know. That has to do with its x-intercepts. For example, something like negative 2x to the 5th plus 4x squared plus 1 could look like the graph where the edges go up and up and up and down and down and down on the right in quadrants 2 and 4. So basically that's the end behavior analysis of polynomials. They either look like the x squared function that we're used to if you got an even degree, or they look like the x cubed function that we're used to if you've got an odd degree. What happens in the middle basically has to do with how many x-intercepts the polynomial has, and that has to do with factoring and popping out solutions and such. What I mean, so if I want to sketch this polynomial, basically I have, when I multiply it out, this is already factored, right? When I multiply it out, I have 3 x's that I'm going to multiply, so it'll be an x cubed. And then because there's this negative 2 that's going to get distributed, I'm going to get negative 2x squared plus a bunch of other terms that I don't care about. So I automatically know my polynomial will go through quadrants 2 and 4 as far as the end behavior is concerned because it's an x cubed problem. Now, I also know that I have x-intercepts. So for my x-intercepts, I'm going to pop out my solutions. When I set y equal to 0, I get negative 3, 4, and x equals 2. Again, each factor pops out a solution when I set the y value equal to 0. That's me assuming that the y value is 0. So I have 3 x-intercepts, 1, 2, 3, 1, 2, and 1, 2, 3, 4. So essentially my polynomial goes through those x-intercepts and connects to the other edge. And again, you also have your TI to refer to when you're sketching these. You will get more of an accurate graph, but the sketching tells you x-intercepts tells me how it crosses the x-axis, and then the end behavior, meaning that leading coefficient, and the degree will tell me what happens in the end behavior of the polynomial. In other words, for this polynomial, as x goes to infinity, f of x goes down below to negative infinity, and on the left side, as x goes to negative infinity, f of x shoots up in the air and goes to positive infinity. And that's basically it for a quick review of polynomials. And the two polynomials we have already looked at in detail and discussed is the quadratic function and the linear function. So the two that we looked at in detail in the previous sections were quadratics, they're polynomials, and linears, they're polynomials as well.